everybody, Harold here. Another video on cybersecurity. Four-part series on I'm going to start a four-part series on password hashing, Hashlib, bcrypt, bcrypt, Argon 2 in that order. Uh, that's the order of security, but the more secure, the more cost. So let's get started. Hashlib. It's a built-in Python model for hashing. It's a one-way function. It just converts data one way into a fixed string of bytes. We call that a digest. You cannot convert it backwards. You can only convert it one way. We use it for password storage, data integrity verification, digital signatures, and blockchain verification. These are async mining machine profit table. It shows you what algorithm is used to mine those coins. And if you look right here, Bitcoin is SHA-256, SHA-256, which we're going to learn about today. And bcrypt is another we're going to learn about. So these are used for blockchain verification. So what we want to do to get started is import Hashlib. If you want to see all the available algorithms, you can say hashlib.algorithms_available. Most common is the SHA-256. Blake is probably the second most common. Those are the ones you could use. We're going to stick with SHA-256 today. So basic string hashing, text equals, for all you Seinfeld fans, hello, Newman. Result equals hashlib SHA-256 text.encode. Encode's required because hashing functions work on bytes. Result returns a hexdigest, which converts binary digest to a readable string. So that's your basic string hashing. We'll do that, and there you go. Turned hello Newman into this long string, alphanumeric string. When I say one way, what I mean by that is you can't decode this. You have to verify it. Let me show you. If you're an admin, you would see something like this: user ID, username, password. You don't see password 123. You just see this hash string. So what happens is you need to verify it. So we get password hashing with verification. What you see here is the original, which is my super secret password, and I've added that $sign for difficulty. Haha. Of hashed equals hashlib dot SHA-256 original, and we'll encode it. And the hash value is the hash.hexdigest. So I want to print the original and then the hash, show you how it worked. So my super secret password 123 turned into this 32-bit hash. And now the admin has to verify. The system needs to verify. They don't decode, like I said. They take their stored hash from the database, like I showed you on the Excel spreadsheet. Then they ask the user to input their password. Then they rehash the password, never even looking at it. And if that hash equals the stored hash, they're okay. Else, invalid password. So let's run that. So enter password So what's my super secret password 123 and password verify. Okay, let's run that again. Just do password 123, enter. That's invalid password. So it's not looking at your password, it's hashing your password and comparing it to the stored hash of your password. So nobody ever sees anything but the hash. You're the only one who knows your password. If you want to incrementally update these things, you can hashlib and chunk. Oh, hashlib shot 256. Nothing. I want to put in hello. Update it, put in a space. Update it, put in Newman. Update it, put in exclamation point. That's a simple thing. If you want to do large encoding, you might want to do it in chunks. The B in here tells Python this whole thing's already an ASCII string, so we don't need to encode. So you'll see the B a lot now. So let's hash that in chunks. Same result. We just get another hash code. You hear about salt. What if everybody had the same password 123? How does it know the difference? Or there are a lot of common passwords like that. How does it know the difference? Salt appends or prepends extra data to prevent rainbow attack. Hackers just throw a rainbow of common passwords until one of them works. Now, if you add salt, that throws them off. So I'm going to import Hashlib and secrets. I do have a video on secrets. It's secure password generation algorithm. Again, my password is my super secret password 123.encode. Salt is secrets.token bytes 16. So I've created a random 16 byte salt. And remember to use secrets and not random for true randomness to add on to my hash password to differentiate it from anybody else who has password 123. Um, and then I'm going to hash that. You've also noticed I've used a different algorithm here. P, P, PBKDF2 HMAC. It's secure password hashing method built into Hashlib. It uses an HMAC key and key stressing, so repeated hashing. But now I've got the salt and the password so that if you and I have the same password, they're not the same hash. If you want to use that PBKDF2 HMAG for more advanced, uh, this is more advanced stuff. Create a function, find hash password, add your salt with secrets token bytes 16, add your key with PBKDF2 HMAC. Use SHA-56 as the algorithm, password encode in UTF-8, add your salt, and run it 100,000 times. That'll return the salt and key. Then to verify the password, you take the stored salt, the stored key, and the password attempt as arguments. Take a new key equals the hashlib HMAC. And if that new key equals stored key, you're okay. So we could say solid keys, hash password Harold123, print stored hash key in hex. Verified Harold123 is true. Verified wrong pass false. So just another password verification using HMAC, and it's true and false. HMAC, hash-based message authentication, ensures integrity and authenticity. So I say key equals B, secret key, B, hello Newman, because we're just using strings. They're already ASCII. And our signature equals a new HMAC key, the message, and the SHA-256 hashlib hexed into a digest. Then we print that signature. So just another HMAC way to ensure integrity and authenticity. So a quick summary, simple hashing, use SHA-256. For more secure, use BBKDF2 HMAC. And for message authentication, use the hmac.new. In a note, these are just the basic hashlib functions. For more secure production apps, you should use bcrypt, or Argon 2. And I'm going to cover those in my next 3 tutorials. So I hope you got something out of this one. If you did, please like it and subscribe. And I'll see you next time. Thanks, everybody.